Oh, that made me a little nervous. 2.3, part 2, all about slope again, but concerning parallel and perpendicular lines. And how do we tell from the slope if it's parallel or perpendicular? And this caught my eye because it has Mr. Potato Head, and if you had me for Algebra 1, I always brought out my Mr. Potato Head. Parallel lines never intersect, but also remember that parallel lines have same slopes. Maybe you didn't know that, but now you do. Perpendicular lines meet to form right angles, and this guy says perpendicular lines have negative reciprocal slopes. I'd rather that he said opposite. And basically, this is the point of the lesson. All right. You don't have to write it in this way, but in a plane, nonvertical lines with the same slope are parallel. So if you have lines with the same slope, they're parallel. And here you have perpendicular. They have this crazy way of saying this. If lines are perpendicular, they have opposite reciprocal slopes. And here, if they're parallel, that's the symbol for parallel. It's not a very good symbol. Slopes are equal. So if you have a slope of 7 and 7, guess what those slopes are? Parallel. If you have a slope of 3/5 and -5/3, these are opposites. How do I know they're opposites? Because of the sign. This sign is positive, this sign is negative, so that's the opposite. And then the reciprocals. In quick review of reciprocal, 3/5 and 5/3 are reciprocals. Your numerator becomes your denominator, your denominator becomes your numerator. In other words, top to bottom, bottom to top. Here's the kicker. If you see 4/7 and 7/4, these are not going to be opposite reciprocals. Why? Because these are reciprocals, but they're not opposites. So this is going to be a neither. Okay, sorry I didn't write up here. These are perpendicular. And that's our symbol for perpendicular if you have forgotten. So you have to be very careful. -1/7 and -1/7, parallel. -7 and 1/7, opposite signs. 7 and 1/7 are reciprocals, so these are going to be perpendicular. And let's take 7 and -1/7. Not very creative there, but these are opposites and they are reciprocals, so they are perpendicular. All right, that kind of gives you an idea here. Example 1, graph the line through 1, -2 that is parallel to the line with the equation of x minus y equals -2. Okay, if I would personally do this out of the blue, I would probably do it a different way, but the book is showing you one way, and plus it reinforces what we already learned in this section. So we're going to kind of stick with the book. Yeah, all right, so here's what they're doing. We have to put the line 1 at -2, that's my point there, and it has to be parallel. Well, how do I know? Well, I got to have slopes that are the same. So I have to figure out what is the slope of this line. I wonder what I could do. Well, graph it. Please note, this is in what form? Standard form. How do I graph from standard form? Oh yeah, I'm going to do 0 blank blank 0. What is that again? That's your x and your y intercepts. This is your y intercept. This is your x intercept. So now we're using it to do something. I put 0 into the problem for x. 0 minus y equals -2. That leaves me with -y equals -2, which means y equals 2. Whoa, 2 goes over here. So I'm going to graph this point, 0, 2. I'm going to put a little x there. I am now going to work on my x-intercept. I put 0 in for y. So I have x minus 0 equals -2. In other words, x equals -2. So I put this in here, -2, 0. Okay, this means I make a line like this. through here. Okay, lovely line. What is the slope of this line? Well, to get from here to here, I rise 2, I run 2. So if I'm rising 2, running 2, I have a slope of 1. Okay, if that's the case and I want to make this line parallel, I got to figure out the slope. Rise 1, run 1. There, I guess I should just do rise 1, run 1, put a dot. Rise 1, run 1, put a dot. And there we go. There's my line that is parallel to the other line. And that's what they want you to do. I know once you have it graphed, you could probably go, hey, I'm just going to match it, but I want you to write out the slope. On a homework quiz or anything like that, I'd want to see what your slope is, like off to the side. Okay, I want to see your x and your y intercepts when you do your assignment. Example 2. This isn't worded quite right, but graph the line through the point 2, 3 that is parallel to the line of the equation 3x plus y equals 6. So I'm going to graph the point 2, 3. Done. It's got to be parallel to the equation 3x plus y equals 6. How am I going to get that equation graphed? I'm going to use x and y intercepts. Why am I doing that? To find the slope. So I'm going to go 0 blank, blank 0. 0 in for x. Right here, this is gone. Then it becomes y equals 6. If you cover it up with your finger or your hand, you don't even have to hardly do any work. 0 goes in for y, cover that up. Then I really have 3x equals 6. So my x value equals 2. So let me graph that. I've got 0, 6. Oh, I'm a little off my graph, but that's okay. And I got 2, 0. Well, that's weird. All right, so 0, 6, 2, 0. Here comes my line in red. This is no fun. Okay, there's my graph. Guess what my slope is? My slope is -3, because I rise -3 and I run 1. So I have a slope of -3, and it says graph the line through 2, 3 that's parallel to this. Well, it's the exact same line in this case. So let me highlight that. Okay, kind of a weird question, isn't it, when they come out that way. Example 3. Graph the line through 2, 1 that is perpendicular to the line of the equation 2x plus or minus 3y equals 3. So let me get my point up there, 2, 1. All right, and if it's going to be perpendicular, I need to find my slope. How am I going to find my slope in this case? I am going to graph and find the slope. So 2x minus 3y equals 3. 0 blank, blank 0, because this is standard form, and the easiest way to graph straight from standard form is to put it 0 blank, blank 0. It's going to become your new favorite thing, I think. 0 goes in for x. All right, so this is gone, and what I'm left with is -3y equals 3. Divide both sides by -3. You get y equals -1. All right? Now I put 0 in for y. Notice how it's a little more complicated, so I'm going to write it out. 2x equals 3. That means x equals 3 halves, because I divide both sides by 2. 3 halves. All right, here I go. I got my point. 0, -1. I've got another point at 1.5, 0. 1.5, 0. Okay, if I make this line, let me go ahead and do this in purple. It's kind of like I'm going up 1 over 1.5. Up 1 over 1.5. Up 1 over 1.5. Not the perfect little thing we got going here, but that's my line. If you look closely here, let me put some highlighted points here. I've got a coordinate right there. I've got a coordinate right there. I've got a coordinate that's on a corner, I should say, in those particular spots. Lovely. So the slope is, let me see, rise 2, run 3. Rise 2, run 3. So I have a slope, rise 2, run 3, of 2/3. So with this dot right here, I'm going to have a slope of 2/3. Rise 2, run 3, put a dot. I'm going to go back the other way. So I'm going to go down 2, back 3, down 2, back 3, and then I go ahead and make my line. Oh, wait a minute. Oh, Mrs. Talley, stop. What am I supposed to do? That's a line that's parallel. Put a note beside that. Yeah, Mrs. Talley just did parallel. What am I supposed to do? Pay attention. Goodness. You guys think sometimes you don't pay attention? Guess what? I just didn't right there. I need to do perpendicular. So if my slope, let's go back to our slope of 2/3, the perpendicular slope is opposite sign, reciprocal of 2/3 is 3/2. So now, let me do this one in a totally different color. Let's go with this funky green. Then my point I start at is 2, 1. So I have to rise -3, run 2. Rise -3, run 2. And then go the other way. Rise 3, run -2. Okay, notice how my slope is actually negative now. That's nice. Comes through here. And the cool thing is, as long as your graph paper is squared up, because every once in a while, like maybe for various reasons, you might have kind of a rectangular kind of graph paper, but generally they're squared up, you will see that this looks like a right angle. Okay? It forms right angles which are perpendicular. Okay, example 4, let's see. Perpendicular. I think I'm going to get you started. I might not finish the whole thing here, but let's see if I can get it right this time. We have the point 2, 1. That seems kind of familiar, doesn't it? Let me just double check. 2x minus 3y equals 3. Do I have the exact same problem? That is no fun. Wow, I feel like I really botched this one. I'd make up another one, but I think we're done. If that is not enough example, please remind me, and I'll go through another one in class. We're going to do an activity, I think, that leads into this anyway. So probably by this point, you're pretty solid on the perpendicular and parallel slopes.